Hi everyone, I'm David and this is my final project. Basically, I wanted to see if machine learning could be used to predict the result of a tennis match. So the motivation for this project comes from a limitation in how people usually predict tennis matches, which is just picking the higher ranked player to win. And using this strategy, you can be around 60 to 65 to 70% accurate, which is a decent baseline, but it ignores a lot of the context in tennis matches, like how some players struggle on certain surfaces or how fatigue plays a role. So my goal was to build a model that doesn't just follow the rankings, but actually identifies the possibility of an upset, which are those specific moments where the favorite is statistically vulnerable. For data, I accumulated 10 years of raw match logs from 2015 to 2024. The raw data comes structured as winner versus loser columns. But if you train on that, the model will just learn that the person on the left column always wins, which is basically data leakage. And so to fix this, I wrote a script to randomize the players into generic player one and player two roles. Then, instead of using raw stats, I engineered differential features like the difference in rank or height to give the model a better signal to work with. I also used the one-hot encoding to encode surfaces, since matches were played on a mix of hard court, clay, and grass. I also compared multiple different models. I used logistic regression as the baseline model. And then I tried two ensemble models, random forest and gradient boosting, which are usually the standard for this kind of tabular data. And finally, I implemented a MLP to see if deep learning could be used to find more complex patterns. Also, to tune the model parameters, I ran a grid search with threefold cross-validation to tune the tree depths and network sizes for each model. And here are the results. It was actually a pretty close comparison between the models, and surprisingly, the neural network or the MLP performed the best with about a 66.4% accuracy, which beats the baseline by roughly around 2.5%. This might sound like a small improvement, but in sports prediction, that's actually a pretty meaningful edge. And I also computed other metrics like precision, recall, and AUC. And as you can see, the MLP and ensemble models all outperform the logistic regression baseline. And I also plotted the feature importance of the random forest model. And if you look at the feature importance chart below, you can see that the rank is actually the most significant predictor in the outcome of a match, followed by age, height, surface, and handedness, which refers to whether a player is lefty or righty. So this tells us that the ATP ranking system is actually pretty efficient. And other features like the surface, height, and handedness act more like tiebreakers for close matches rather than the primary drivers. And to show you what this model looks like, I ran two specific scenarios through the model. So first, I simulated a match between Carlos Alcaraz and Yannick Sinner, who are currently the rank one and rank two players in the world. I inputted their respective stats like their height, and the model outputs a probability of 49.6% of Carlos Alcaraz winning. So it pretty much correctly recognized that despite the ranks, this is basically a coin flip, which is pretty accurate in reality. And then I gave it a rank 1 versus rank 100 matchup and inputted the rank 1 and rank 100 player stats. And here the confidence is around 80% chance, 81% chance of the rank 1 player winning, which makes sense. And so in conclusion, this project proves that while rankings are the most significant predictor in tennis, there are other factors that can play a role, such as age, height, surface, and handedness. It also showed that deep learning can perform well as other ensemble models. And for future work, the next step would be getting more granular data. Right now, I'm just using high level stats, but if I could add other stats like serve speeds or the head-to-head record, I think that would push the accuracy of the model to even higher. Thank you for watching.